Hi all, and I want to start this video, and actually for the rest of the semester then we will be talking about human-machine interface, or HMI. I've posted an archived Micro 800 file in Blackboard for you, and I'll have that information for you in the learning content. One of the first things that we're going to do, and what I'm going to have you do, is look at a version of Lab 7 that you would have done in class, and also you did a discussion on Lab 7 this semester. So I want to start by the fact that I did Lab 7 in Micro 800 or CCW format. And when you unarchive that file that I'll put in Blackboard, it will be the project that I'm about to show you right now. Lab 7 for CCW was written using an 820 processor with a IF2 and an OF2 plug-in module attached for the analog input and output. You will see that there are several programs. There are 3 ladder programs, 2 structured text programs, and a function block program. And I only did the function block program as an oscillator to show you how it's done. I would have probably normally done that as a function like we already did in Lab 1, where I can just import that function. But I wanted to show you how it was done in function block. So when we open these files or these programs, I'll open them up. This is what I call main, and you'll see that I had to do some data conversions. First of all, the plug-in module for the analog input, when I hover my mouse over, you'll see that the data type is a unsigned integer, and I wanted the PV to be a DINT, so I had to do a data conversion on that. You will also then see that I've created the 3 different scaling methods. This is the scaling method for ladder, the scaling method for function block, and the scaling method for the structured text. And you'll see that it's selected by using the tag scaling method and a value. And I'll show you on the HMI screen where that number comes from. Now, before I go any further, you will not be able to simulate the HMI operation. That is not built into the CCW software, at least in version 12. I'm hoping they will eventually allow us to also simulate the HMI, but at this time you can't. But you can simulate this program running on your simulator, and I'm going to show you how to get that started. So let me open thermostat, and these subroutine or these programs, if you relate them back to Lab 7 and the Studio 5000 program code, and please do, so that you can see the relationship and the correlation between how I did it in Studio 5000 and how I'm doing it in CCW. And again, I want to stress, gentlemen, that there is no right or wrong way for me to have done this. It's just the way that I happen to do it, and there might be a better way to do it. I don't know. I'm sure. I mean, there could be. So anyway, there's the thermostat program. There's a cooling control program, and again, you can look back at the Studio 5000 version of this. There's a temperature units conversion, which I did in structured text, and it's fairly straightforward. It's pretty easy to understand. the process status display, which I had asked you a question about in one of the discussion topics. Well, now that it's here and you'll be able to run this, you could actually check your answer to see when you in fact get a process status variable equal to 0 or equal to 1 or equal to 2. And again, I'm going to show you where that comes into play on the HMI. And then I did the oscillator in function block just because I could. All right, and just to show you that how it's done in function block. There are global variables being used. All of my input outputs are shown. And this, by the way, right now is for the 820 processor. You'll see that there are a bunch of global tags which I have initialized to some values, and that's so that the processor will not fault when I first go online with it. There must have been some divide by zeros occurring or some math error that was faulting the processor. So I initialized some of these variables, and then you'll see here are the plug-in modules, and I've aliased the ones I'm using, and that's it. Now again, HMIs in CCW, in order to reference them, or the objects, you must have global variables. So the HMI can only access the global variables. When we look at the HMI screen, or I'm sorry, let's go back a minute. Here's user-defined functions. Here you'll see that I have the scaling in ladder. So let me open that function, and you'll see that I'm doing it with discrete math. I could have used the scalar instruction. It would be just fine, but I did it using discrete math. Here's the same thing done in structured text. And again, when you look at this structured text, I think you're going to find it's pretty easy to read and pretty easy to understand. And here it is in function block. Here it is in function block. I'll get there. Where I did use the scalar instruction. And you'll see I had to do some data conversion because of my data type mismatches. And how that got scaled. Then in this FSP, what I'm calling FSP is what I'm doing is I'm calculating the fan speed, or displaying actually the fan speed. That's what FSP stands for in percent. So that if you enter in the 50%, you'd get 50. It would show you 50. All right, now in this project, I have an HMI added, and I named it EMEC 245 gain error. And you'll see a tags area. If I double click on tags, you'll see that these are the tags that the HMI is using. We're not using any alarms. We're not using any recipes. But here are the screens. If I drill in, you'll see I have 4 different, actually there's 6 screens, but we're not using the bottom 2. Those were created automatically by CCW. But I created these 4 screens. And the reason I'm giving you this code is so that you can explore the HMI objects and how the HMI objects are configured. Because even though creating an HMI is really simple and really monotonous, really, because it's like you're doing the same type of thing over and over again, there are a lot of properties that can be set on most of, if not all of the objects, the graphic objects that you'll be placing on the screen. And just show you, I mean, I can't show you all of them. The video would be hours and hours and hours if I had to show you every single property. So I thought what I would do is I would give you this program code and let you explore screens that I've already built and already tested to be working, so that you can see what type of object it is and how it's actually properties are set and what variables are tagged to it. So when we double click on main, you'll see that this is the screen that came up, and I'm going to increase the size of this. There's a magnifying glass here. I'm going to do it twice only because I know on this fairly small laptop screen that it fits well. And you'll see how I laid this out. Now, your layout might have been different, and in the HMI screens that I'm going to have you actually build with a different program, I want you to use your imagination and I want you to use your creativity. I'm going to show you a copy or a printout of the screens that I created for that program and identify the object types. However, I want you to explore. I want you to learn how to do this. So let me pause just for a moment, and I want to first of all show you the connection between the PLC and the HMI. So the graphic that I am showing on the screen is actually in the Lab 8 that you would have been doing if we were on campus. And I'm going to make Lab 8 available to you just as an FYI. There's nothing you can really do with it at home other than browse through it. I mean, it's 73 pages because there's an enormous amount of information in that lab. And also, it will go through for you a step-by-step procedure for creating HMIs with Factory Talk View ME, which is Machine Edition. The process is similar, but yet different. So anyway, on here, I'm showing you the control logics rack that we had in the lab or have in the lab. I'm showing you an HMI, and we are connected with Ethernet. So behind your training panels, there was an Ethernet switch, and there were Ethernet cables going from each device to the switch, and from the switch it went out to what I'm calling here the plant enterprise, when it's actually, it could be the world, whatever, it could be the corporate offices, so it can go out to other places. Now inside the PLC, we have the program code that's running. So let's say that we just have a couple of switches here. All right, and this has the tag of stop, and this has the tag of start, and there's no field device assigned to this. I'm going to have these two buttons on the HMI. So over on the HMI screen, I would then create some objects for this. And what I would create is an object called a momentary push button. There's momentary push buttons, there's latch push buttons, there's various other types. But I would create an object for it. It's a graphic, and I'm going to show you how to do this in another video. But you would drag the object in, and let's say we drag a momentary push button in. And right now, I could set the properties to that. So I could say, I want the text here to be, and it's too small here, but to be start, and I'm going to make it green. I can change the color of it. But the key thing is that I have to link this object to a variable or to a tag. So I would link that object to the start tag if that's my start push button. So there's an area where I would then map this out to the start tag of the PLC, so that when this button is pressed, it goes from a 0 to a 1. When that 1 is then sent over the network, you have to tell it what PLC you want it to go to. So I would say I want it to go to this PLC, and I would do that by the IP address. And it would find that PC or that particular PLC, come into the processor, and it would change the status of that tag. So when you tap on that object, it would generate a logic 1, gets attached to the start tag, and changes the status in the ladder. That's how simple it is. We have to have the PLC tags. We create objects of various types, sizes, shapes, colors, and map those objects to tags within the PLC. So back at our main screen for this lab, when you click on an object, you'll see that there are sizing handles. But I'm going to now right click on it and say properties. And it momentarily brought up my properties, but it's along the side here. I'm going to click on properties, and I'm going to pin this so that it stays there. And within those properties, you can see, first of all, that this is a multi-state push button. That's what the object name is. And in that, you can also then see all the properties that I can set. So I can change the size of this object. I can change the visibility of this object simply by using a tag in the processor to say, you know what, when this particular thing runs, I want this button to be, I'm just going to pull a number, 12 by 12 pixels. When this particular thing runs, I want this button to be green, and I want it to be 22 pixels by 22 pixels. So there's a lot of different ways you can customize. You can see that my border color I chose is blue. My border style is raised. It kind of gives it that look as if the button is sticking out from the panel. You can set a border width. You can set corner radiuses, so you can make things a little squarer, rounder. I chose to be a rectangle. The states are a collection, and you can do some help on that if you want. There are then some just common things like this is the actual height. This is how far from the left edge it is. I let the name the same. When you enter the object, it automatically assigns a name. If you want to change that name, you can. It doesn't matter. This tells you how far it is from the top of the screen, and this tells you how wide it is. So that if I wanted to reproduce this button like I did over here with these three, I would have the size of it, and I can physically go in there and make them all the same size. Here's the important part. I mean, everything's important, but the connections. This particular object needs at least a write tag. This tag is called scaling method, and you saw that tag name or that variable name in the main ladder routine. So that particular object is linked to that variable over in the ladder logic. I didn't need an indicator tag because an indicator tag would also change what is being displayed on this object. And I'll show you that in another object. And then a lot of this navigation stuff you won't need, because first of all, you can't run this screen in the simulator. You're just going to be building it. If you send it to me, I can run it and test it for you. I have a panel here at the house, but you can set focus on an object. You can enable the touch, which you should always have true for a touch screen. So you can do a lot of different things with this. Now, some objects also have more than just these properties. Some objects, if you double click on the object, you'll see that you get a states window. This is a multi-state push button. Therefore, I can have multiple different states. I chose to have 3 states, and the error state comes in automatically. I can add additional states. I can, if I select it, I could delete a state. I can insert new states. So you can have as many states as you want. And the way this button works is on each tap of that object, it changes the value. So the first time before you tap it, it's 0. The first time you tap it, it'll be a value of 1. The second time, it'll be a value of 2. And in that ladder code, you saw I had equal signs there for that tag of scaling method. If it's equal to 0, do this. If it's equal to 1, do this. If it's equal to 2, do something else. I can change the background color for each one of the states. So right now, state 1 or state 0 is being displayed because it's blue. State 1 will be this brownish orange color. State 3 will be green. And if an error occurs, the button will turn red. And my background fill style is the background color. So whatever color I choose, that's what it's going to fill. When you're doing this, you don't really need a fill color because you can't see the fill anyway. Over here is where I would then put my caption text for each one of these states. So for state 0, I have it being LAD scaling. If I click in there and click the button with the 3 ellipses, it brings up a text box so that I get LAD scaling. And then you would just say OK. State 2 is function block diagram scaling. Do the same thing. You see that you could also add a date variable and a time variable. So you can add a bunch of different things. I also said that I wanted my caption text for this state to be white, and the font was going to be Tahoma. For this state, I wanted the text to be black. For this state, I wanted it to be white, and if it's an error, I want the text to be yellow. And you can scroll across. You can change the font's type. You can change the font size. You can make it bold or not bold. You can make it italics. You can underline. You can justify it either center, left, right, up, down, whatever. You can choose word wrapping so that if the words are too long, they'll wrap around. You can, I've never used caption scroll, so I'm not sure what that does. Caption blink will say that when that caption comes up, it'll literally blink. You don't need it. You don't need an oscillator. It will do it for you. You can even insert images in these objects so that maybe I'd want a picture of a ladder in there, and I can have a picture of a ladder and say, okay, what is the image name and where is it? And I can display that image. And then if you're using an image, which I tend not to do, you don't want your screens to get real busy because they get confusing. You can then position things. You can set the image backgrounds. So there's a lot of information that can be configured. So I'm going to leave this setting at 2, and I'm going to say OK, and see what it does is it displays the settings that I already had selected. And if you hover your mouse over, it'll tell you that the right tag is scaling method and the indicator tag is undefined. These objects are let me click on it, are maintained push button. This is a maintained push button. What that does is when you push it, it turns on, and you have to push it to turn it off. And these are also maintained push buttons. And they are to use to select manual cooling, auto cooling, manual heat, or auto heat. And again, the same things hold true over here. You set the properties with a write tag. This time it's a write tag, and that's going to write the value of a 0 or a 1 to that particular tag. These indicator lights, that's what these are. These are used as indicator lights, but they're nothing more than a multi-state indicator. You again can set the properties of this indicator. When you double click on this, now you can set how many states do I want? What color do I want each state to be represented with? What text do I want displayed? What color? So there's a lot of options that you can change to make your screens look well and navigate well. And you scroll across. Now, not every object has the double click thing. So if I double click on this one also has it, so that I can set my background colors and my caption texts. This right here is current operation, the select scaling routine. That's just plain text. It's just static text. That's all it is. This right here is also a multi-state indicator. These were also multi-state indicators. I used this one as being round, this one's being square. You can see shape is rectangular. And when you double click, you'll see that this indicator has 6 different values plus the error. You'll see I'm changing the background colors. I'm changing the caption text. This is the object that piece of structured text code uses to display messages to the user, so that when the value is 0, it's auto heating and cooling. So it tells the operator, I'm auto heating and I'm auto cooling. If its value is 1, I'm auto cooling and manual heating. So that these text areas, that text will actually change. This is no cooling with auto heating, cooling and heating, no cooling, heating. You can read this stuff. So, and then I said, I want to change the caption text also. So again, there's a lot you can do. So I'm going to choose, I guess I'm going to choose this one just so that right now I'm on state 0, but now when I say OK, now I'm on state 1 and it says cool and heat. These two objects right here are numeric displays. Now if I double click on that, which I am, there is no double click option there. You can just set these properties the way you want things to display. And what that's going to do is it's going to display a value from that's stored in a variable. And in this case, I'm reading, it's a read tag, and I'm going to read the value from the tag degrees F. This one, I'm going to read from the tag degrees C. So all that is a display. Now this one is a numeric entry. This particular object, the user can tap on to bring up the touchpad. You've done this in the lab. You tapped an object and it brought up the touchpad so you can enter a value. And that's exactly what this is. So it's called a numeric entry. You will take notice that there is a right tag of set point. That right tag is saying that when I tap that and I enter in the value and press the enter key on the keypad, I'm going to write that value to the set point tag in the processor. Now, I have something missing in this particular program, and that is I need an indicator tag. And I want to make that also the set point. Notice how I'm doing this. I clicked in and then dropped this down and I just picked the tag I want. I want this to be set point. Now, why do I need an indicator tag? I need the indicator tag so that the indicator tag is going to go out to the PLC and read the value that I just entered and display it within that numeric entry. So in order to get that to work, I needed to have an indicator tag. There are some other tags. You'll see there a handshake tag and a notify tag. I personally have never used them. I would have to look them up in the help files to find out. You can also set your maximum and minimum number range. You can set your fonts, the whole thing. These buttons are go to screen buttons. The go to screen button, you can again change the colors and all that stuff. If I double click on it, you can enter text into it. And you have to have the screens created ahead of time. You don't have to have anything on the screens, but you have to have the screens there. So this one is going to go to, let me find where it is, screen to 3 input config. So it's going to open this screen over here. Output config is going to open the output config screen. Display tune, let me undo that because I just moved it a little bit, is going to open up screen 2. So there's screen navigation buttons. This guy up here in the corner, if I click on it, you'll see that it's a go to terminal config. On the main screen of your project, you should always put a go to terminal config, because that's how you end the screen from running, so you could get back to the configuration settings of the actual HMI terminal. Now, I would have liked to hide that like I did in the lab ones where I had it up in the corner, but I left that at least just with a border on it so that I knew where it was, and you can see that it is a go to terminal config button. There's no settings other than if you want to add text, if you want to change the color and the size of it, but you don't have to give it any tags. It literally just ends this process and goes back to the configuration screen of the terminal. If I just click on a blank spot of the screen, you also get screen properties. So I can change the background color of the screen. I can add a description and do all kinds of other things. Okay, so those are some of the basic objects. To open up another screen, I would just double click. There's the input screen. You can explore these objects just like we did over on the other screen. This is just static text, which if you double click, you can enter text. And I have another go to config screen there. You don't really need that button there, but I put it on there. This button is a back one screen. That will just take you back to the previous screen. I can open up another one. This is a return. This is back one screen again, which I labeled return. And if you double click, you can put your text in. And then there was the monitor tuning screen. So there's some multi-state indicators, there's some display, numeric display, some numeric inputs. Notice I tend to color code my numeric displays versus my numeric inputs or my enables type controls, just to kind of give the operator a hint. Oh, I can touch that one. You really want to check if your company has a standard that they use for that, or you can create your own standard if you're the guy doing it. So that's just another screen. Okay, so I don't want to go any further. This video is already getting out of hand with time, but I'm going to have you, what you can do is you can open this project up and explore this project. Actually, there is one more thing that I need to do before leaving you on this. And that is, you know what, I'll do that in the next video. This one's getting a little bit too long, but I have to show you how to change the processor type. And I just remembered that might take a little while because there's a couple of little changes that have to be made. So that'll be it for this. Again, I'm going to give you the archived file of this so that you can open it and explore how this interface, how this stuff is set up. I'm going to have one more video in this particular project just to show you how to change the processor over so that you can actually simulate. Again, you cannot simulate the HMI screens. They're just going to do nothing at all for you, but you can simulate the program running by entering values into tags and variables and watching how the program runs. Okay, so next video, try to keep it shorter. I'll show you how to change the processor in this. Thanks a lot.